So there is no test in chapter 16, but here's the couple problems that you really need to be able to do, and that is qualitative separation of cations. So suppose I've got a solution that's got calcium ions, iron ions, silver 1 ions, and potassium ions. How would you separate those ions out if they're all in solution? And the only way you can solve this problem is by knowing the solubility rules backwards and forwards. Again, you don't have to memorize them all, but in the real world you could look this stuff up, but we're not in the real world. You're trying to figure out how to pass this AP test. So what I would do is the first thing is utilizing the chloride rules, because that silver, lead, copper 1, and mercury are not soluble with chlorides, bromides, or iodides. So the first thing I would do is I would add any type of chloride. I'm just going to pick sodium chloride because sodium doesn't react with anything, because you do have to worry about sometimes the cation reacting with something else further down the road. So if I had sodium chloride, the chloride is going to react with the silver. Now we'll get silver chloride. The chloride does not react with iron, calcium, or potassium. Okay? And I don't care that I now have sodium ions floating through. So now the silver ion is gone. Okay? Second step, okay? Sometimes you want to utilize sulfate or hydroxide rules. So calcium sulfate is not soluble. Calcium, barium, lead, they are not soluble. So what I would do is I would add sodium sulfate. By adding sodium sulfate, the sulfate is going to react with the calcium, produce calcium sulfate, which is not soluble, so that'll precipitate out. So this is what's called selective precipitation, precipitating one thing at a time. So now the calcium's gone. Okay. Would the sulfate react with the sodium ions that were in there? No. That's why you want to make sure you choose a good, you wouldn't want to have used barium chloride, for example, because if you use barium chloride, the barium would react with the sulfate. So that's why picking sodium as the way to deliver your anion is pretty safe. Okay. Third step, you would want to now add hydroxide. And when I add the hydroxide, the OH will react with the iron. It's not going to react with potassium or the sodium. So then you've got iron reacting with the hydroxide to produce, okay? And then that's a solid, and then potassium's left in solution. So you now have separated out all the ions that you set out to do. Okay? So there are many ways to do this. This is just one way, so don't think like, oh, this is the only way. There are other ways, but this is probably the simplest one. Usually, you want to utilize the chloride, bromide, iodide rules with separating out lead, mercury, silver, copper 1. Then actually usually you go to a hydroxide rule, but in this case I went to a sulfate rule.